Right now, as you're watching this video, as you're sitting comfortably in your chair, maybe eating snacks, definitely not thinking about cosmic horror, there's a star 650 light years away that's dying. Not slowly dying like our sun, which has billions of years left, not peacefully dying like a red dwarf, which basically just fades away. Now, this star is dying violently, catastrophically, spectacularly. This star has been dying for the last 40,000 years. It could complete its death tomorrow or in 100,000 years. We literally don't know. And when I say we don't know, I mean the world's best astrophysicists are basically just making educated guesses and hoping they're alive when it happens. The star is Betelgeuse. You've probably heard of it. You might even be able to point to it in the night sky. It's the red supergiant that makes up Orion's shoulder, the star that dimmed so dramatically in 2019 that astronomers thought, holy shit, this is it, it's happening. Spoiler alert, it didn't happen. But the fact that professional scientists, people with PhDs, people who've dedicated their lives to studying stars, collectively lost their minds over a dimming event should tell you something. When Betelgeuse explodes, and it will explode, it won't just be another point of light in the sky. For weeks, possibly months, it will be the third brightest object in Earth's sky after the sun and moon. You'll see it during the day. It'll cast shadows at night. Birds will sing at midnight thinking dawn has come. Nocturnal animals will be confused. Religious groups will probably declare it the end times. Your Instagram feed will be nothing but supernova selfies for months. And here's the thing that should really mess with your head. Betelgeuse might have already exploded. Light takes 650 years to travel from Betelgeuse to Earth. If Betelgeuse exploded in 1374, during the Black Death, while medieval peasants were dying of plague and blaming witches, that light, that announcement of one of the universe's most violent events, is still traveling toward us. It could arrive tonight, tomorrow, while you're in the bathroom, while you're sleeping. You could walk outside after watching this video, look up at Orion, and witness the most spectacular celestial event visible from Earth in recorded human history. Or you could wait your entire life and die disappointed, never knowing if you missed it by days or decades. Tonight, we're going to explore every terrifying, beautiful, mind-breaking aspect of Betelgeuse's impending death. We'll talk about what it means for Earth, what it means for astronomy, and what it means for you personally to live in the maybe last generation to see Orion with two shoulders. Because make no mistake, Betelgeuse isn't just dying, it's dying in a way that will literally change our sky forever. And we have front row seats to the greatest show in the universe, whether we want them or not.
All right, my anxious astronomy enthusiasts, doomsday preppers, and people who accidentally clicked this thinking it was about the movie character, welcome to minutes of existential anticipation mixed with cosmic science and a healthy dose of it could happen any second now paranoia. Before we dive into the impending stellar apocalypse, let me address the elephant in the room. Yes, Betelgeuse is pronounced Betelgeuse. Yes, saying it 3 times won't make it explode faster. I've tried. We've all tried. The star doesn't care about our pop culture references. Betelgeuse, the vital statistics of a dying giant. Let's get acquainted with our dying friend. Official name, Alpha Orionis, because astronomers love making simple things sound fancy. Distance, 650 light years, plus or minus 150 because measuring cosmic distances is hard. Mass, 15 to 20 times our sun's mass. It's been losing weight recently. Radius, 700 to 900 times our sun's radius. It can't decide on the size. Age, 8 to 10 million years old. A baby by cosmic standards, a geriatric by massive star standards. Temperature, 3,500 Kelvin. cooler than our sun, but try not to touch it, luminosity 100,000 times our sun, compensating for something. Let me put Betelgeuse's size in perspective, because numbers like 700 solar radii mean nothing to our monkey brains. If Betelgeuse replaced our sun, its surface would extend past Mars's orbit. Earth, Venus, Mercury, Mars, all would be inside the star. We wouldn't be orbiting it. We'd be vaporized within it. Jupiter would be getting uncomfortably warm. Saturn would be sweating. The bloated monster. Betelgeuse isn't just big, it's wrong big. It's so large that it barely holds itself together. Its surface gravity is about 50,000 times weaker than Earth's. If you could somehow stand on its surface, you can't, it's gas, you'd sink and die, you'd weigh about as much as a paperclip weighs on Earth. The star is so bloated that it's not even properly spherical. It's lumpy. It has convection cells, bubbles of hot gas rising and falling that are each larger than Earth's orbit around the sun. Imagine bubbles in boiling water, except each bubble could swallow our entire inner solar system. The great dimming that broke the internet. In October 2019, Betelgeuse started dimming. Not the usual, oh, it varies a bit dimming. This was, holy crap, is this it dimming? By February 2020, it had lost 2/3 of its brightness. Astronomers lost their minds. Twitter exploded. News outlets ran headlines like, Betelgeuse about to explode? The star that had been steadily visible for all of human history was fading before our eyes. Then, of course, COVID happened, and we all had bigger problems than a dying star. Because apparently, the universe thought 2020 wasn't interesting enough already. Turns out, Betelgeuse had basically sneezed. A massive convection cell had risen to the surface, cooled, and released a cloud of dust that blocked some of the star's light. It was stellar congestion, not stellar death. But here's the terrifying part. We were so convinced it was about to explode because Betelgeuse has all the symptoms of a star in its final death throes. Irregular pulsations, check. Mass ejections, check. Dramatic brightness variations, check. Spectral changes indicating core instability, check. It's like a patient showing every symptom of a heart attack but somehow still walking around. The doctors are just standing there with the defibrillator waiting. Humanity's relationship with a dying star. Every human civilization that could see the stars has looked at Betelgeuse. The ancient Egyptians called it the shoulder of Orion. The Chinese called it the fourth star of 3 stars. Their counting system was different, don't ask. Indigenous Australians have Dreamtime stories about it. Medieval Arabic astronomers named it Betelgeuse, which got corrupted into Betelgeuse. For 100,000 years of human existence, Betelgeuse has been there. A constant, a navigation aid, a piece of art painted on the sky. And we might be the last generation to see it as a star. The next generation might only know it as a nebula, a cloud of expanding gas where a star used to be, a celestial gravestone. Think about that. Every human who ever lived before us saw Betelgeuse. Not all of our descendants will. We exist at the knife edge of cosmic history.
To understand why Betelgeuse is dying and why its death will be so spectacular, we need to talk about stellar economics, not money, energy. Stars are basically cosmic corporations, and their business is fusion, the fusion economy. A star's entire life is a battle between 2 forces: gravity, trying to crush everything inward, and radiation pressure from fusion, pushing outward. As long as these balance, the star lives. When fusion stops, gravity wins. Game over. Explosion time. Young stars like our sun fuse hydrogen into helium. It's efficient,
clean-ish and can last billions of years. 1 kilogram of hydrogen becomes 0.993 kilograms of helium. That missing 0.007 kilograms, that becomes energy. E equals mc squared, baby. Our sun has been doing this for 4.6 billion years and has enough hydrogen for another 5 billion. It's the cosmic equivalent of a fuel-efficient sedan. Betelgeuse? Betelgeuse is a monster truck that's been doing donuts in the cosmic parking lot for 8 million years, and now it's running on fumes. The death spiral of massive stars. Here's where massive stars like Betelgeuse get screwed by physics. Stage 1. Hydrogen fusion. 90% of life. Burns hot and fast. Betelgeuse blew through its hydrogen in about 8 million years. Our sun takes 10 billion years to do the same thing. Betelgeuse lived fast and is dying young. Stage 2. Helium fusion. 8% of life. When hydrogen runs out in the core contracts, heats up, and starts fusing helium into carbon and oxygen. This lasts maybe 1 million years. The star swells into a red supergiant. This is where Betelgeuse is now. Stage 3. Carbon fusion. 0.1% of life. Carbon fuses into neon, sodium, and magnesium. Lasts about 1,000 years. 1,000 years! Human civilization is older than that. If Betelgeuse entered carbon fusion when Vikings were raiding England, it would be running out now. Stage 4. Neon fusion. 0.01% of life. 1 year. 1 year! If Betelgeuse started fusing neon last Christmas, it's about to give us one hell of a New Year's fireworks show. Stage 5. Oxygen fusion. 0.001% of life. 6 months. If it started on your birthday, mark your calendar. Stage 6. Silicon fusion. 0.0001% of life. 1 day. 24 hours. If Betelgeuse starts fusing silicon at breakfast, it explodes before breakfast tomorrow. The iron catastrophe. Here's the cosmic joke that kills massive stars. Iron. Every fusion reaction up to iron releases energy. Hydrogen to helium, energy profit. Carbon to oxygen, energy profit. But iron is fusion's dead end. Fusing iron costs energy instead of releasing it. When Betelgeuse's core becomes iron, fusion stops. No more radiation pressure. Gravity finally wins. What happens next occurs in less than 1 second. The fastest disaster in the universe. T-minus 0.25 seconds. The iron core, about the size of Earth but with the mass of our sun, collapses. T-minus 0.2 seconds. The core reaches nuclear density. A teaspoon would weigh 100 million tons. T-minus 0.15 seconds. Protons and electrons are crushed together into neutrons. T-minus 0.10 seconds. The core rebounds, sending a shockwave outward. T plus 0.00 seconds. The shockwave hits the infalling outer layers. T plus 0.01 seconds. Boom. The explosion releases more energy in that 1 second than our sun will produce in its entire 10 billion year lifetime. For a brief moment, Betelgeuse will outshine its entire galaxy. And we might see it happen tonight. The neutrino warning system. Here's something cool and terrifying. We'll know Betelgeuse has exploded about 3 hours before we see it. When the core collapses, 99% of the energy is released as neutrinos, ghostly particles that barely interact with matter. These neutrinos travel at basically the speed of light and pass through the outer layers of the star like it's not even there. The visible light from the explosion has to fight its way through the star's outer layers. This takes about 3 hours. So neutrino detectors on Earth, Super Kamiokande in Japan, IceCube in Antarctica, will suddenly go crazy with detections. Astronomers will have 3 hours to point every telescope on Earth and in space at Betelgeuse before the light show begins. Imagine being the grad student monitoring the neutrino detector when it happens. Hey, professor, you might want to look at this. Also, should I call NASA? The president? My mom?
Let's talk about the most elaborate cosmic prank of the 21st century, the Great Dimming of 2019-2020. This wasn't just a star varying in brightness. This was Betelgeuse giving humanity collective anxiety for 4 months. October 2019, the beginning of the end? It started innocently enough. Amateur astronomers noticed Betelgeuse looked a bit dimmer than usual. No big deal. Betelgeuse is a variable star. It gets brighter and dimmer on several different cycles. A 400-day cycle, a 5.9-year cycle, a 100-day cycle, plus random variations because it's a dying star and doesn't care about your need for predictability. But this dimming was different. It kept going and going and going. By December 2019, Betelgeuse had dimmed to magnitude 1.6, fainter than it had been in modern observational history. For context, it's usually around magnitude 0.5. Lower numbers equals brighter because astronomers hate intuitive systems. The media frenzy. Headlines started appearing. Is Betelgeuse about to explode? Supernova imminent? Will Betelgeuse destroy Earth? No, but thanks for the clickbait. Scientists baffled by dimming star. Scientists weren't baffled. Scientists were excited. There's a difference. Baffled is, we don't know what's happening. Excited is, we don't know what's happening and we have front row seats. February 2020, peak dim. Narrator. By February 7th, 2020, Betelgeuse hit magnitude 1.614, about 36% of its normal brightness. To put this in perspective, it went from being the 10th brightest star in the night sky to the 21st. Orion's shoulder had basically dislocated. Professional astronomers were scrambling. Every major telescope that could see Betelgeuse was pointed at it. The Hubble Space Telescope cleared its schedule. The Very Large Telescope in Chile went into overdrive. Even radio telescopes were listening just in case. The theories flew thick and fast. Theory 1, pre-supernova dimming. Some supernova dim right before exploding. It's like the star taking a deep breath before screaming. Was this it? Theory 2, enormous star spot. Maybe Betelgeuse had developed a massive cool spot, like a sunspot, but the size of Jupiter's orbit. Theory 3, dust cloud. Perhaps Betelgeuse had burped out a cloud of dust that was blocking the light. Theory 4, pulsation overlap. Maybe multiple dimming cycles had synchronized, creating a super dim event. Narrator. The truth, when we finally figured it out, was somehow both mundane and spectacular. The truth, Betelgeuse literally blew its top. Using the Hubble Space Telescope and ground-based observatories, astronomers pieced together what happened. A massive convection cell, roughly 100 times the size of Earth, rose from deep within Betelgeuse. This cell was cooler than the surrounding surface. When it reached the surface, it exploded outward. The explosion ejected about 10 trillion tons of material, roughly twice the mass of our moon. This material cooled into dust as it flew away. The dust cloud blocked our view of the star's southern hemisphere. Betelgeuse had essentially sneezed, and the sneeze was blocking our view. The star ejected twice the mass of our moon like it was nothing, and we're calling it a sneeze. This is why astronomical scales break human brains. The April 2020, the recovery and what we learned. By April 2020, Betelgeuse started brightening again. The dust cloud dispersed, the star returned to normal, astronomers collectively exhaled. But we learned something crucial. Betelgeuse is more unstable than we thought. The Great Dimming showed us that Betelgeuse can have massive surface mass ejections, events that would destroy our entire solar system as casual occurrences. It's not just dying, it's dying violently, piece by piece in real time. The aftermath. Permanent changes. Here's the scary part. Betelgeuse hasn't fully recovered. Its surface is now asymmetric. It's pulsating irregularly. The convection patterns have changed. It's like watching someone have a stroke and trying to figure out if they're recovering or about to have another one. Recent observations show the southern hemisphere is still cooler, new convection cells are forming chaotically, the star's shape is more irregular than ever. Mass loss has accelerated. The Great Dimming might not have been a false alarm. It might have been a warning shot. Betelgeuse is telling us, I'm dying and it's going to be messy.
All right, let's stop teasing and get to what you really want to know. What will we actually see when Betelgeuse explodes? Spoiler alert, it's going to be the most metal thing you'll ever witness. Hour 0, the neutrino storm. Before we see anything, Earth will be hit by a wave of neutrinos. About 10 billion neutrinos will pass through every square centimeter of your body. Don't worry, you won't feel it. Neutrinos are so weakly interacting that you could shoot one through a light year of solid lead and it probably wouldn't hit anything. But our neutrino detectors will scream. Every neutrino observatory on Earth will simultaneously detect the spike. Scientists will immediately know Betelgeuse has died. Then begins the longest 3 hours in astronomical history. Every professional and amateur astronomer on Earth's night side will point their equipment at Betelgeuse. Social media will explode. News outlets will scramble. And somewhere, some influencer will try to figure out how to monetize humanity's first observed supernova. Hour 3, first light. The first visible sign will be subtle. Betelgeuse will brighten slightly, then more, then more. Over the course of about 10 days, it will brighten from magnitude 0.5 to magnitude -10. For comparison, full moon, magnitude -12.7. Venus at brightest, magnitude -4.6. International Space Station, magnitude -6. Betelgeuse supernova, magnitude -10. It will be the third brightest object in Earth's sky, brighter than any planet, brighter than any satellite. You'll see it during the day, a pinpoint of light visible even at noon, though please don't stare at the sun trying to find it. Days 10 to 100, the peak performance. For about 3 months, Betelgeuse will dominate the night sky. Here's what Earth will experience. Nighttime effects. Shadows cast by starlight. First time in human history. Newspapers readable by Betelgeuse light alone. Nocturnal animals confused by the false dawn. Night photography ruined worldwide. Astronomy of faint objects impossible. Imagine trying to explain to your kids why the night sky has a bonus moon that doesn't move. No, honey, that's not the moon's baby. It's a dead star. Yes, stars die. No, our sun won't. Actually, let's talk about something else. Daytime visibility. You'll be able to see it in broad daylight if you know where to look. It'll appear as a bright dot near the sun, depending on the season. This has only happened once in recorded history, the supernova of 1054 that created the Crab Nebula. The colorful death. Narrator, here's something most people don't realize. The supernova will change colors. First week, blue-white as the shockwave breaks through the star's surface. Weeks 2 to 4, white as the explosion reaches peak brightness. Months 2 to 3, yellow as the ejecta cools. Months 4 to 6, orange-red as heavier elements dominate the spectrum. Year 2 plus, deep red fading to infrared. It's like watching a cosmic rainbow in slow motion, if rainbows were caused by nuclear fusion and stellar death. What we'll learn from the light. The spectrum of Betelgeuse's supernova will tell us its exact mass, finally, its core composition at death, the speed of the ejected material, what elements it created, how much energy was released, and whether it formed a neutron star or black hole. It'll be like the star's dying confession, except written in electromagnetic radiation and only readable by spectrographs. Very poetic, very useless if you're not an astrophysicist. The human reaction. Let's be honest about what will really happen. Week 1. Science Twitter goes insane. News channels bring on every astronomer they can find. Conspiracy theorists claim it's aliens, government weapons, or the end times. Amateur astronomers become temporary celebrities. Telescope prices skyrocket. Month 1. Supernova parties become a thing. Religious movements interpret it as divine signs. Astrologers make up new nonsense about what it means for your love life. Scientists plead with people to stop asking if we're all going to die. Hollywood announces 17 Betelgeuse movies. By month 3, humans will be bored of the cosmic spectacle that happens once per civilization and go back to arguing about politics and celebrity breakups. We're very good at normalizing the extraordinary. The long fade. After peak brightness, Betelgeuse will slowly fade. Year 1, still visible to the naked eye, magnitude 2 to 3. Year 2, barely visible in cities, magnitude 4 to 5. Year 3, only visible in dark skies, magnitude 6. Year 5, invisible to the naked eye, magnitude 8+. Years 10 to 100, visible only through telescopes. Years 100 to 1000, expanding nebula visible in large telescopes. For the rest of human history, assuming we make it, where Betelgeuse once stood will be an expanding cloud of gas, a nebula. Future generations will point telescopes at it and see the calcium that could have been their bones, the iron that could have been their blood, the carbon that could have been their DNA, all floating in space. We'll be looking at the raw materials of life, prevented from ever becoming life because the star died before those elements could be incorporated into new solar systems. It's beautiful and tragic and very, very space.
All right, let's address the cosmic elephant in the room. Is Betelgeuse going to kill us all when it explodes? Will its radiation strip away our atmosphere? Will it trigger mass extinctions? Will it at least give us superpowers? Spoiler, no, and definitely no. But the real answer is more interesting than certain death or radioactive spider powers. The kill zone. How close is too close? For a supernova to seriously damage Earth's biosphere, it needs to be within about 30 light years. At that distance, the radiation would destroy 50% of the ozone layer, UV radiation at Earth's surface would double, mass extinctions would likely occur, cancer rates would skyrocket, the food chain would collapse. Betelgeuse is 650 light years away. That's 20 times the kill distance. We're safe. Mostly. Probably. Let me explain why I'm hedging. The radiation menu. What's coming our way? When Betelgeuse explodes, it will release 1. Photons, light. Visible light, pretty, but harmless. UV radiation, mostly absorbed by atmosphere. X-rays, also mostly absorbed. Gamma rays, the spicy ones, but still okay at this distance. 2. Neutrinos, 10 billion per square centimeter. Completely harmless, will pass through Earth like it's not there, might give physicists Nobel Prizes. 3. Cosmic rays, high-energy particles, will arrive years after the explosion. Slightly increased radiation exposure might affect satellite electronics. So we're safe from the radiation, but that doesn't mean there won't be effects. The ozone situation. Even at 650 light years, Betelgeuse's supernova will have some effect on Earth's atmosphere. The good news? Ozone depletion will be less than 1%. Recovery will take only a few years. No mass extinctions, no major climate effects. The concerning news: slight increase in UV radiation, possible minor effects on phytoplankton, small increase in skin cancer rates, potential disruption of some ecosystems. So basically, Betelgeuse will give Earth a mild sunburn. Wear SPF 50 instead of SPF 30 for a few years. The real danger is humans panicking and doing something stupid, which, let's be honest, is our specialty. The electronic apocalypse that won't happen. Some doomsday scenarios suggest the supernova's radiation will fry all satellites, destroy the power grid, wipe out the internet, send us back to the Stone Age. Reality check: some satellites might experience glitches, radio communications might have minor interference, GPS might be slightly less accurate, your phone will be fine.
The radiation intensity at Earth will be about 1/400,000th of what the sun delivers daily. It's like worrying that a candle 20 miles away will give you a sunburn while you're already standing in daylight. What if Betelgeuse was closer, just for fun and nightmares? Let's imagine Betelgeuse at different distances. At 100 light years, brightness of a second full moon, significant ozone depletion, 25%, major ecosystem disruption, elevated cancer rates for decades, possible minor extinction event. At 50 light years, brighter than the full moon, 50% ozone depletion, mass die-offs in ocean surface life, agricultural collapse possible, civilization threatening but not ending. At 30 light years, the kill zone, daylight at midnight for weeks, complete ozone layer destruction, mass extinction event, end of civilization as we know it, survivors would envy the dead. At 10 light years, brighter than the sun for days, Earth's atmosphere stripped away, oceans boiled, surface sterilized, planet becomes Mars 2.0. But Betelgeuse is 650 light years away, so we're fine. Well, fine in the sense that we won't die from this particular cosmic event. We've got plenty of other existential threats to worry about. Climate change, nuclear war, Twitter. Historical supernovae, our track record of survival. Humans have survived multiple supernovae during our evolution. The Vela supernova, 11,000 years ago, 800 light years away, visible during daylight for months, possibly depicted in cave paintings. No mass extinctions, humans were fine, still invented agriculture. SN1054, the Crab Nebula, 6,500 light years away, recorded by Chinese astronomers, visible during day for 23 days. No reported deaths from the supernova, anyway, created pretty nebula we still photograph today. SN1572, Tycho supernova, 8,000 light years away, brighter than Venus, Tycho Brahe wrote a book about it, challenged the idea of unchanging heavens. Still didn't kill anyone. Notice a pattern? Every supernova in recorded history has failed to destroy Earth. Betelgeuse will continue this disappointing trend of not ending the world. Sorry, Doomsday Preppers, your bunkers remain unnecessary. At least for this. Our cosmic shields, Earth's defense systems. We have the magnetosphere. It deflects charged particles, creates pretty auroras as a bonus, has protected us for billions of years, and will handle Betelgeuse just fine. The atmosphere, 100 kilometers of air, is excellent radiation shield, absorbs most harmful radiation, self-repairs ozone damage, has survived worse than Betelgeuse. Distance, the inverse square law is our friend. Radiation intensity drops with distance squared. 650 light years is very, very weak radiation. Space is big, radiation is diluted. It's like nature gave Earth a bulletproof vest, a force field, and then placed the shooter on another continent. We're gonna be fine. Disappointed astronomy fans, but fine.
Right now, at this very moment, Betelgeuse is the most watched star in the universe. Not by aliens, probably, but by humans with an unhealthy obsession with stellar death. We've turned stalking a dying star into a science, and an art, and honestly, kind of a compulsion. The Betelgeuse Surveillance Network. Professional observatories watching 24/7. Very large telescope in Chile takes stellar selfies in infrared. Hubble Space Telescope, the paparazzi of space. ALMA in Chile listens to Betelgeuse's radio screams. Keck Observatory in Hawaii watches the surface convulsions. And Chara Array in California makes 3D maps of the bloating. We have more telescopes pointed at Betelgeuse than the NSA has surveillance cameras in a Best Buy. If this star so much as hiccups, 17 grad students will write papers about it. The Amateur Army. But it's not just the professionals. Thousands of amateur astronomers check Betelgeuse every clear night. They measure its brightness. They note its color. They photograph it obsessively. There's actually an organization called the American Association of Variable Star Observers, AAVSO, with over 2,000 members whose hobby is literally watching stars die. They've been monitoring Betelgeuse since 1893. Imagine explaining that hobby at parties. What do you do for fun? Oh, I watch a star 650 light years away waiting for it to explode. Cool. I'm gonna go talk to literally anyone else now. The computer models, playing God with stellar death. Scientists have created thousands of computer models of Betelgeuse's death. They tweak the parameters. What if it's 15 solar masses, 20, 25? What if the core is more carbon-rich? What if rotation is faster? What if it has a companion star we haven't detected? Each model predicts slightly different. Explosion dates, anywhere from tomorrow to 100,000 years. Brightness levels, magnitude -8 to -11. Remnant type, neutron star versus black hole. Explosion asymmetry, round versus lopsided. We're basically playing Stellar Death Simulator 2024, except the graphics are math equations and the gameplay is waiting decades for results. One star, thousands ways to die, zero consensus on when. The neutrino early warning system. Here's the coolest part of our Betelgeuse surveillance. We've set up an early warning system that would make the Pentagon jealous. Super Kamiokande, Japan. 50,000 tons of pure water, 13,000 light detectors, located 1 kilometer underground, can detect neutrinos from Betelgeuse. Ice Cube in Antarctica, 1 cubic kilometer of ice, 500 and 1600 optical sensors, frozen into Antarctic glacier, turns the entire ice sheet into a detector. When Betelgeuse explodes, these detectors will go from recording a few neutrinos per day to thousands per second. Automatic alerts will be sent to every major observatory on Earth. Within minutes, every telescope capable of seeing Betelgeuse will swing toward it. It'll be like the cosmic equivalent of everyone pulling out their phones when a celebrity shows up, except the celebrity is dead and made of exploding plasma. SNEWS, the Doomsday Alert System. There's actually a formal network called SNEWS, Supernova Early Warning System. When multiple neutrino detectors trigger simultaneously, SNEWS sends alerts to every major observatory, the International Astronomical Union, space agencies worldwide, science journalists from Maximum Hype, and your astronomy app, probably. The alert will read something like, probable galactic supernova detected, neutrino burst observed, optical brightening expected in 3 hours. This is not a drill. Imagine being the person who sends that alert. The pressure, the excitement, the knowledge that you're announcing the astronomical event of the millennium. No pressure. Of course, there have been false alarms. 1987, equipment malfunction at Mont Blanc detector. Alert sent out, astronomers scrambled, no supernova, much embarrassment. 2011, software glitch at Super K. Recorded impossible neutrino burst, brief panic, turned out to be a computing error, grad student probably cried. 2019, the Great Dimming. Everyone thought, this is it! Media went crazy, Betelgeuse was just dusty, astronomers pretended they weren't disappointed. At this point, when Betelgeuse actually explodes, half the astronomy community won't believe it. Sure, another false alarm. Oh wait, why is there a second sun in the sky?
The remnant, what Betelgeuse leaves behind. When Betelgeuse explodes, it won't just disappear. Oh no, it's going to leave a corpse. A stellar corpse that's either the universe's densest disco ball or a region where space-time gives up and goes home. Let's talk about what Betelgeuse becomes after death. Option 1, neutron star, the universe's most extreme object. If Betelgeuse's core is less than about 3 solar masses after explosion, it becomes a neutron star. The stats that break physics. Diameter, 20 kilometers, the size of a city.
Mass, 1.4 to 2 solar masses. Density, 100 trillion grams per cubic centimeter. Surface gravity, 200 billion times Earth's. Magnetic field, 1 trillion times Earth's. Rotation, up to 700 times per second. A teaspoon of neutron star material would weigh as much as Mount Everest. If you dropped it on Earth, it would punch through the planet like a bullet through tissue paper, exit the other side, and probably come back for another pass. The lighthouse of death. If the neutron star is spinning and has its magnetic poles misaligned with its rotation axis, it becomes a pulsar. It'll sweep beams of radiation across space like a lighthouse from hell. If Earth happens to be in the path of these beams, we'll detect regular radio pulses, maybe X-ray pulses too, each pulse marking one rotation, a cosmic metronome keeping perfect time. Imagine Orion's shoulder replaced with a hyper-dense cosmic lighthouse spinning hundreds of times per second, screaming radio waves into the void. That's so much more metal than a regular star. Option 2. Black hole, when physics says, nope. If Betelgeuse's core is more than 3 solar masses, gravity wins completely. The core collapses past neutron star density, past quark star density, past any density physics can describe, into a singularity. Black hole Betelgeuse would be event horizon, about 18 kilometers diameter, mass, 5 to 8 solar masses, temperature, practically absolute zero, emission, only Hawking radiation, basically nothing, visibility, completely invisible. If Betelgeuse becomes a black hole, Orion will literally have a hole in its shoulder, a region of space where nothing, not even light, can escape. The constellation will be permanently wounded, bearing a scar that space-time itself can't heal. The Betelgeuse Nebula, a stellar graveyard. Regardless of whether it becomes a neutron star or black hole, Betelgeuse will create a spectacular nebula. Year 1 to 10. Expanding shell of superhot gas, traveling at 10,000 kilometers per second initially, glowing from radioactive decay, visible in small telescopes. Year 100 to 1000. Shell expands to several light years, cools and dims, collides with interstellar medium, forms complex shock structures. Year 10,000 plus. Nebula spans 50 plus light years, creates stellar nursery. New stars form from Betelgeuse's ashes. Circle of stellar life continues. In about 50,000 years, Betelgeuse's remnant will look like the Crab Nebula does today, a beautiful, colorful cloud hiding a violent past. Instagram influencers of the future will take selfies with it, completely unaware they're posing with a corpse. The Cosmic Factory, what Betelgeuse will create. Supernovas are the universe's element factories. In its final second, Betelgeuse will create more heavy elements than exist in our entire solar system. Elements created: iron, enough to make billions of Earths. Nickel, radioactive, powers the light show. Cobalt, also radioactive. Gold, yes, actual gold. Platinum, more valuable than the GDP of Earth. Uranium, naturally radioactive. Everything heavier than iron. Every gold ring, every platinum catalyst, every uranium atom in every nuclear reactor, they all came from supernovae. When Betelgeuse explodes, it'll create enough gold to make every human on Earth a billionaire. Too bad it'll be floating in space, radioactive, and traveling at 3% the speed of light. But hey, if you want to get rich from Betelgeuse's death, just wait 100,000 years for the nebula to cool, build a spacecraft capable of traveling 650 light years, and start mining. Easy money.
We need to talk about the elephant in the room, the conspiracy theories, the alternative explanations, the people who think big astronomy is hiding the truth about Betelgeuse. Buckle up, this is going to get weird. Conspiracy number 1. Betelgeuse already exploded. The theory: Betelgeuse exploded years ago, but the government is hiding it to prevent panic. The evidence: the Great Dimming was the explosion. NASA edited the images to make it look normal. Astronomers are sworn to secrecy. The elite are already in bunkers. Yes, because nothing says effective cover-up like tens of thousands of amateur astronomers worldwide all keeping the same secret. Have you met astronomers? They can't even agree on whether Pluto is a planet. Reality check. You can literally go outside and see Betelgeuse tonight with your eyes. Unless the government is projecting a fake star somehow, which would honestly be more impressive than just telling the truth. Conspiracy number 2. Aliens are preventing the explosion. The theory: advanced aliens are keeping Betelgeuse stable because its explosion would damage their infrastructure. The evidence? Betelgeuse should have exploded by now, according to who? Unusual spectral lines that are completely normal. The star's irregular behavior, which is regular for dying stars. And that one blurry photo that shows alien megastructures. Ah yes, aliens traveled hundreds of light years to perform stellar life support on a dying star instead of just moving their stuff. That's like humans trying to stop a volcano by holding the lava in with their hands instead of just evacuating. Conspiracy number 3. Betelgeuse is a biblical sign. The theory: Betelgeuse's explosion will herald the apocalypse, second coming, rapture, etc. The evidence? Vague Bible verses about signs in the heavens. Numerology involving Betelgeuse's distance and brightness. The star is red, like in Revelations. 2020 dimming equals beginning of end times. Every astronomical event is the apocalypse to someone. Solar eclipse, end times. Comet, end times. Mars at opposition, believe it or not, end times. We've been predicting the apocalypse since we invented language, and we've been wrong 100% of the time. But sure, this time it's real. Conspiracy number 4. The time traveler warning. The theory: time travelers from the future are warning us about Betelgeuse through coded messages. The evidence? John Tidor, fake time traveler, mentioned a star in Orion. Nostradamus wrote something vague that could mean anything. The Simpsons predicted it. They didn't. Mysterious Reddit posts from deleted accounts. If time travelers were real and wanted to warn us about Betelgeuse, maybe they could be more specific than watch the shoulder star posted on 4chan at 3 a.m. Just a thought. Conspiracy number 5. CERN will trigger the explosion. The theory: the Large Hadron Collider will create a quantum effect that triggers Betelgeuse's explosion. The evidence? Quantum entanglement exists. True, but irrelevant. CERN creates tiny black holes. They evaporate instantly. The timing is suspicious. It's not. Scientists are playing God. They're playing with protons. Yes, a particle accelerator on Earth is going to affect a star 650 light years away through quantum. That's like saying your microwave will cause the sun to sneeze. Physics doesn't work that way. Physics doesn't even want to work that way. The kernel of truth in the crazy. Here's the thing. Governments probably do have contingency plans for a Betelgeuse supernova. Not because it's dangerous, but because, 1, mass panic is always a possibility. 2, communications might be affected. 3, doomsday cults might do doomsday cult things. 4, economic impacts from panic. 5, someone needs to coordinate observations. There's probably a dusty folder in some government office labeled Protocol for Visible Supernova Event that mostly says, tell everyone to calm down, in 47 pages of bureaucratic language. When Betelgeuse actually explodes, here's what will happen in conspiracy land. Day 1, the government knew and didn't tell us. Week 1, it's not a real supernova, it's insert theory. Month 1, the radiation is worse than they're saying. Year 1, the explosion was triggered by insert scapegoat. Decade 1, Betelgeuse never existed, it's all CGI. No amount of evidence will convince some people. We could fly them to the neutron star remnant, let them touch it, they'd die instantly, and their ghost would still claim it was fake. That's the beauty and horror of human psychology.
Let's get existential for a moment. We're a species that lives for maybe 80 years, watching a star that's lived for 10 million years, waiting for it to die. We're mayflies hoping to witness a redwood fall. The audacity is almost beautiful. The temporal mismatch problem. Betelgeuse operates on stellar time. We operate on human time. The mismatch is staggering. Betelgeuse's timeline. Formation to death, 10 million years. Red supergiant phase, 100,000 years. Final collapse, 1 second. Supernova visibility, 100 plus years. Human timeline. Individual lifespan, 80 years. Recorded astronomy, 5,000 years. Telescopic observation, 400 years. Modern astrophysics, 100 years. We're trying to catch a specific second in a 10 million year lifespan. It's like trying to photograph a specific electron and a specific atom and a specific molecule in the ocean while blindfolded from space. The inherited obsession. Astronomers have been passing down Betelgeuse observations like family heirlooms. 1836, John Herschel notes its variable. 1920, Michelson measures its diameter. 1995, Hubble images its surface. 2020, the Great Dimming obsession. Today, continuous monitoring. Each generation of astronomers inherits the Betelgeuse watch from the previous one. Here, kid, I've been watching this star for 40 years. It might explode on more watch, or your students, or never. Good luck. It's the ultimate academic long game. Entire careers spent watching something that might not happen for 1,000 generations. The supernova lottery. Other candidates. Betelgeuse isn't our only supernova candidate. We're watching Eta Carina, 7,500 light-years away, with 100 plus solar masses, already had a great eruption in 1843, could explode tomorrow. Would be spectacular, but distant. VY Canis Majoris, 3,900 light-years away, is the largest known star by radius. Losing mass rapidly, another any day now candidate would be dimmer than Betelgeuse. Antares, 600 light-years away, is Betelgeuse's rival in mythology. Similar size and stage. Could beat Betelgeuse to the punch. Would be equally spectacular. We're like cosmic ambulance chasers, watching every dying star and placing bets on which one goes first. My money's on Betelgeuse. Nah, Eta Carina for sure. Meanwhile, the stars don't care about our gambling problems. The meaning of witnessing cosmic death. What does it mean for humanity to witness a supernova? Scientific meaning. It confirms our understanding of stellar evolution, provides data for nuclear physics, tests our models of element creation, advances neutrino astronomy. Cultural meaning. Shared global experience, reminder of cosmic scales, confrontation with mortality, wonder at natural beauty. Personal meaning. Once in a civilization event, connection to the cosmos, existential perspective, and a story for your grandchildren. When Betelgeuse explodes, every human who sees it will share that moment. Rich, poor, every nation, every language, all looking at the same dying star. For once, humanity united and witnessing something bigger than our petty differences. Or we'll find a way to argue about it on Twitter. Probably that. What we tell the next generation. How do we prepare kids for a sky that might change? See that red star? It might explode while you're alive. Will it hurt us? No, it's too far away. Why do we watch it then? Because it's beautiful and rare, and it teaches us about the universe.
What if it doesn't explode? Then you tell your kids to watch it. We're creating generations of Betelgeuse watchers. Kids who grow up knowing a star might die during their lifetime. That's a different relationship with the cosmos than any generation before us had. So here we are, minutes into discussing a star that might explode tonight, tomorrow, or long after our great-great-great-grandchildren have forgotten our names. We've covered the science, the speculation, the conspiracy theories, and the philosophy. What's left? Maybe just this. Betelgeuse is a mirror. What Betelgeuse reflects about us. Our curiosity. We'll spend centuries watching something that might not happen just to understand it better. Our arrogance. We think stellar timescales should conform to human lifespans. Our fear. We immediately ask, will it kill us, about everything cosmic? Our wonder. We find beauty in stellar death, art in destruction. Our unity. Every human culture has looked at this star and wondered. Our legacy. We document everything for future generations who might witness what we can't. Betelgeuse doesn't care that we're watching. It doesn't know we exist. It's just a massive ball of gas following the laws of physics toward an inevitable end. But we care. We watch. We wait. We wonder. The invitation. Tonight, after you finish this video, go outside. Look up. Find Orion. 3 stars in a row for the belt, Betelgeuse as the left shoulder from our perspective. Look at that red star. Really look at it. You're seeing light that left Betelgeuse when the world was a different place. 650 years ago, the Black Death was ravaging Europe, the Ming Dynasty ruled China, the Aztec Empire was rising. No human had seen the Americas from Europe. The printing press didn't exist. That light traveled for 650 years to reach your eyes tonight. And the light you're seeing might be some of the last normal light Betelgeuse ever emitted. Or it might have another 100,000 years worth coming. We don't know. But that's the beauty of it, the not knowing, the waiting, the possibility that any night could be the night. We live in a universe where stars explode, where we understand why they explode, and where we're lucky enough to potentially witness one explode. When it happens, when Betelgeuse finally explodes, and it will explode, remember this moment. Remember when you learned about stellar death, about neutrinos and iron cores and neutron stars. Remember the waiting, the watching, the wondering. And when that new star appears in Orion's shoulder, brighter than anything except the sun and moon, visible during the day, casting shadows at night, remember that you're witnessing something magnificent, the death of a giant, the birth of new elements, the continuation of a cosmic cycle that started 13.8 billion years ago and will continue long after we're gone. Betelgeuse could explode tonight. It probably won't, but it could. And that possibility, that any moment could be the moment, makes every night an adventure. Every glance at Orion, a lottery ticket. Every clear sky, an opportunity. So keep watching, keep waiting, keep wondering. Because one night, maybe tonight, Orion's shoulder will burst into cosmic flame, and those who are watching will witness the universe's most spectacular fireworks show, a star's final gift to any species lucky enough to evolve eyes, build telescopes, and care about things that don't affect them directly. That's us, the watchers of Betelgeuse, the witnesses of stellar death, the only known beings in the universe who will mourn a star they've never met. Betelgeuse is still there, still red, still dying, still keeping its secrets, but maybe not for long. Maybe not for long.